Which of the following is a root of the equation? And this is the equation. It looks like a pretty complicated quadratic equation. And the natural tendency here is to cross multiply to get rid of the fractions. But I'm sure you'll agree that cross multiplying over here is going to make matters more complicated. So let's see if we can factorize the denominators. We have 3 times x squared minus 6 over 12 is the common factor. So we take out a 12 and we are left with x minus 2 squared. That's x squared minus 4x plus 4 minus, if you take out a 12, from a 12 you're left with a 1. So that's a minus 1. And on the right hand side we have 2x squared minus 3x on the top. And on the bottom we see that we can take out a 4 as a common factor. And 4 times 3 is 12. So we have 12 times x squared minus 4x plus 3. Oh, and notice that 4 minus 1 is also equal to 3. And therefore, the two denominators are exactly the same. So let's change this side. Let's get rid of the 4 minus 1 and write a 3 there. The two denominators being equal will eventually cancel out. But before that, let's just factorize the denominators. On the top, we have 3 times x squared minus 6. And on the bottom, we have 12 times x squared minus 4x plus 3 can be factored into x minus 3 times x minus 1. And on the other side, we have 2x squared minus 3x over 12 times x minus 3 times x minus 1. Like we said, this means we can cancel out the two denominators, meaning we are multiplying both sides of the equation with 12 times x minus 3 times x minus 1. So this is gone, this is gone. And also notice that x cannot be equal to 1 or 3. Because if x is one of these two numbers, the denominators are going to be equal to 0. And in a fraction, you cannot have a 0 in the denominator. So let's take it up over here. We have the numerator on this side is equal to the numerator on this side. Let's open up the parentheses. We have 3x squared minus 18 is equal to 2x squared minus 3x. Let's get everything on one side. 3x squared minus 2x squared is x squared. And if we take the negative 3x onto this side, it becomes a plus 3x, meaning we are adding 3x to both sides. Minus 18 is equal to 0. And this expression can be factored as x plus 6 times x minus 3 is equal to 0. So we know that either x is equal to negative 6 or x is equal to 3. But we have already come to the conclusion that x cannot be equal to 3. Therefore, x has to be equal to negative 6. Answer choice A.
Okay, let's just move our equation over here. Now, one possible approach is to plug each answer choice into the equation and see which ones work. Of course, that would take a while. Now, another approach is to see if we can first simplify this equation. So let's completely factor the numerator and denominator on both sides of our equation. When we do this, we get the following. At this point, recognize that since x plus 12 over x plus 12 typically equals 1, we can eliminate these two binomials from the left-hand side to get the following. At this point, recognize that the expression on the left-hand side is completely identical to the expression on the right-hand side. As such, we might conclude that every answer choice is a possible value of x. This, however, is not true. Now, to begin, remember up here when we eliminated these two expressions because we concluded that x plus 12 over x plus 12 must equal 1. Well, this is not always the case. Notice what happens when x equals negative 12. When we plug negative 12 into our expression here, we get the following. And when we simplify, we get 0 over 0 is equal to 55 over 14. So as you can see, our equation does not hold true when x equals negative 12. As such, negative 12 is not a possible value of x. Now the same kind of thing applies down here. Notice what happens when we let x equal 2. Well, when we plug 2 in for x, we get the following. And when we simplify it, we get this. Now some may say that 15 over 0 is equal to 15 over 0, but this is not true. 15 over 0 is an undefined value, so we cannot say that an undefined value is equal to another undefined value. So as such, 2 is not a possible value of x. Finally, what about this area? What happens if we let x equal negative 1? Well, when we do this, we get the following, and this simplifies to be 0 equals 0. So x equals negative 1 is a solution to our equation. So the only two restricted values for x are negative 12 and 2, and all other values are possible. So our answer is A, C, D, and F. Okay, let's begin by taking a closer look at this given inequality. Now, if x is greater than y, we can conclude that x minus y is greater than 0. We'll use this information shortly. Now let's take a closer look at this inequality. Notice that we can factor the left-hand side as follows. This is very useful because we already know a little bit about x plus y. We are told that x plus y is greater than 3. Now, if x and y are both integers, we can conclude that x plus y will be 4 or greater. Now notice that we have 4 or greater multiplied by x minus y, and the product is less than 8. Well, we already know that x minus y is greater than 0. Now, from our given information here, we can also conclude that x minus y must be less than 2. Here's why. Let's say that x minus y does equal 2. Well, here we have 4 or greater multiplied by 2, and this product is not less than 8. As such, we know that x minus y must be less than 2, and we also know that x minus y must be greater than 0. So given this information, it must be the case that x minus y is equal to 1. In other words, x and y differ by only 1. Well, since x and y are both positive integers, what are some possible values of x and y? Well, y could equal 1 and x could equal 2, y could equal 2 and x could equal 3, and so on. Now the question tells us that x plus y must be greater than 3, so we can eliminate this pair. We also know that x squared minus y squared is less than 8. So let's plug our x values and y values into this expression and see what happens. We'll begin here. If y equals 2 and x equals 3, our expression evaluates to be 5, and this is indeed less than 8. If y equals 3 and x equals 4, our expression evaluates to be 7, and this is also less than 8. For the next pair of values, the expression evaluates to be 9, and this is not less than 8. Now, as you can see, there's a pattern developing, and every successive pair of values we plug into the expression will always be greater than 8. So there are only two possible values for x, 3 and 4. The greatest of these is 4, so we'll go up here and enter 4.
So in this question, we're asked to compare these quantities, and we have this relationship inequality in terms of absolute value. Now, some cases you might be able to deduce this condition with the quantities given here, and I think you do want to look in that direction first, but I don't see any way of seeing the equivalence here. So in that case, I would go into selecting numbers. So for example, I might start with a equal to 5, and I have to pick numbers that satisfy this condition to begin with. So b could be, for example, 0, and there's no constraint on whether it's positive or negative. So you'll notice that this pair that I've selected does indeed satisfy the inequality, and that needs to be the case before you can even go into comparing the quantities. So 3 is greater than 2, so that works, which means this pair is acceptable. Then I'm going to plug these values into column A and column B. Column A would be 7, and B would be minus 2. In this case, column A is greater. Now my goal is if I can come up with another pair that satisfies this inequality where this would flip, meaning column B would become greater. So now I have to think about in terms of maybe I want to make A a negative number. So for example, A is minus 5. So in this case, column A is minus 3. Now I have to also pick a suitable value of B. So I'll plug in minus 5, so it's minus 5 minus 2. So that's 7. So I have to pick B in a way that it satisfies this inequality. And for example, if I pick B to be, say, 3, because that would be 7 is greater than absolute value of 5, which is true. And then when I plug into column B, 3 minus 2 is 1, and 1 is indeed greater than minus 3. So now column B is greater. So with two examples, I've shown that we cannot determine the relationship, and that's, of course, is the fastest way if it happens to be D. Because if this problem, somehow column A was greater, let's say, then my examples would have given me the outcome to be that both column A in both cases are greater. So then in that case, I would have to think of a more general approach, which likely would be there. But in cases where there is no clean way to take the information in the main stem and make conclusions about these quantities, often you just have to use examples. So in summary, in this case, the relationship cannot be determined. The answer is D.